Okay, Epic pen. So maybe half an hour or so, we will first discuss about the theory. Okay, and then we will go to the practical. But I feel that until unless we know why we are using a particular technology, what was the existing challenges for the industry, then it's, see, commands you can find from a lot of sources. But the thing is that why we need it. So that is more important. So uh, if you are, using any technology, then or anything which is related to DevOps, especially, right? So you first need to know that why we need to do, why we want that technology, or why we need to understand that tool. So we have discussed about Git. So this is developer. Developer is writing the code into some programming language and put it into the GitHub, right? That we have seen. No. Then we have discussed about Maven. Maven is a build automation tool, right? And we have seen that we can create the jar files, var files, whatever the executable files. So Maven is not an Maven is a tool. So it is the part of the process, right? So now after that we have seen how these files we can put it into some Artifactory server. JFrog we have seen. Now we are having our jar files. Now next part is that we need to go for the testing. Okay, we need to go for the testing. Right. So this jar file, I need to give it to the testing team. So now this is a testing server, for example. In this testing server, you need to execute this jar file or var file, could be anything. Okay, consider it's a web server, and you need to deploy this application. So you are pushing all the jar files, right? And you are pushing all the jar files which are required to execute your project, right? So uh, right. So right. So you need to push all the jar files on the testing server, right? And 1 second. Yeah. So you need to push all the jar files or var files into the testing server, right? So once the jar files or var files in the testing server, tester will start working on it. Manishika, you there?
Yes, yes.
Okay, so what we are talking about that in the DevOps cycle, this is a developer. Developer is pushing the code to the version control system like GitHub. And after that, there is a Maven. Maven takes that source code and convert it into the jar file. So for you, I have not discussed about the artifact, but there is a artifactory, which is JFrog. And we are pushing those files into the artifactory so that we can manage the releases of our application execution. So these jar files are the executable files which we are putting it into the artifactory. After that, what we want to test this. So we want to give it to the testing team. Now question to both of you, anyone can answer. Before giving this to the testing team, you want to test by yourself your application. What this is called, testing by yourself, when you divide your uh, code into small set of codes. What what kind of
Unit
testing that
testing.
is called? Very good.
Unit testing.
And who does this unit testing?
Developer.
Developer only. Very
Available.
good. So I'm not talking about that unit testing here. I'm talking about the testing which is to be done by the uh, testers or testing team. So there are many tools, depends upon what type of testing you're doing. I'm taking very generic one where web application you want to test. So Selenium is one of the uh, tool which is used for the web applications, microservices, mobile applications, such kind of testing. We use Selenium. So consider this is the test automation. So what is the meaning of test automation? Means there will be script which is testing your application. It is not a means that script is written by a developer only, but the script is testing because we know that in DevOps end-to-end CI/CD pipeline, it is a automation, right? So we plug in our automation tool. Now there are some challenges. First challenge is that you are writing a code on your own machine. So this is your own machine and you are writing the code here and you have installed everything, right? Uh, to run your program. For example, if you are writing a code in Java, you have installed JDK. Okay, you don't need JRE explicitly because JDK includes JRE. And consider you are using the dependencies. So Nikhil, if you remember that we have discussed that, right? Dependencies is only for the development machine, but when you create the package, those dependencies are not getting included into your jar file when you run the mvn package command. So it will only related to that application. If you want to use your local repositories, jar files, which you have added as a dependency into your project, so that you need to explicitly mention that this is my jar file. Okay, so those things are not there. So because but on development machine it is working fine, everything. But when it goes to the testing team, for example, or production, then it gets filled because some dependencies are missing, or maybe you are using Java 25 here, but in testing server or production server, it is Java 8. Okay. Now there is always a gap between development team, testing team, and production team. So testing is done by the testing team. In the production, it is done by the operation team. They will operate, and uh, they don't know the programming language. They don't know what to do. They are having one implementation plan where which is created by you as a developer, and you give it to them, and they are basically they are following that implementation plan and implement the solution. If some issues comes, then they will directly report to you and they will revert back the changes. Now that is a big challenge actually sometimes. Um, so if you are not having a full exposure of the server where you want to deploy it, then this will be a big challenge for the development machine. Even though you are writing that these are the prerequisites that is required on the servers, maybe you can miss something, maybe permission part you miss it, or maybe something which is not uh, which is not related to the development, but it is related to the admin level. Like for example, you are running a service, but service is not fetching the data from the database because it is running with a different user which does not have the access to that particular server. So there are so many challenges. Now, the question is that who will resolve it? In real time, basically, if something goes wrong, for example, you have installed Java 8 here, or you are having certain path which you have hard coded on your application. When you give it to the operation team, that path does not exist, and maybe it's a glitch in your code, which basically because of that issue occurs. It happens. It is very common. So now operation team will start blaming the development team, and development team say, hey, you don't know this path exists. So that's why I have not written the code that if this path does not exist, create this directory. So they are saying, no, we are following your plan, and there is always a conflict. Okay. So when there is a conflict, that why it happens, who will resolve it? Will it the development team? Will it the production team? Right? So there, if you are following the DevOps process, then it is responsibility of the DevOps engineer to resolve this conflict. That, so mean to say, whatever is, if something is running on development machine, it should definitely run in all the environments, whether it is testing environment, whether it is production environment, it should run in all the environments. Now, what DevOps engineer will do, because see, if it is a application logic issue, then development teams will say, okay, we will look into that. If it is infrastructure related thing where servers implementation comes into the picture, then DevOps engineers responsibility is to set up the environment in such a way that it works in all the areas like testing, production, etc. So what we were doing when there were no containerization, I will come to the containerization. First, let us understand the scenarios, understand the problems. So once we understand the problem, then we will resolve it, or we will see that how containerization helpful in that. So now you are, so what DevOps engineer has thought? He thought, let me have a virtual box. Okay. On that virtual box, I will create one virtual machine. And I will, whatever development machine is giving to the testing team, I will deploy it here on this virtual machine. And I will open some ports, right? Whatever is required on that machine. Fine. Now, if everything is fine, then I will clone this machine. I will clone this machine, and same machine I will be using in the testing environment and production environment. That solves the issue. Do you understand what I'm trying to say, Manishika?
Yes.
Okay. So I will create a virtual machine. I will means before giving to the testing team, I will take it on the one virtual machine. I will create it, and I will deploy the code, and whatever the challenges, I will resolve it in this virtual machine. And then I will clone this virtual machine, and I will give it to the testing environment, same virtual machine, and same for the production. Nikhil, you think that it will resolve the issue at some extent? Nikhil, you there?
Yes, sir. Am I audible?
Yeah.
So I have one doubt. Suppose we are creating the virtual machine, but we are testing it on the real environment or real website. So how it's going to help that? Because in virtual environment, we are having some different configurations. But when we are testing on the real environments, like in QA or maybe on different environment?
Then basically what we will do, for example, there is one application, web application is running inside this. What I will do, I will do a port forwarding. Okay, so I will say port 80 is to be opened. So now whether it wants to, you want to integrate with other virtual machines, right? So ultimately everything I can access it either on the virtual machine level or the host machine level, right? So with the port forwarding, so for example, you want to test your web application. Okay, access it at port number 80 and your testing team, they will start testing on this. If it is integrated with some other application, then for example, there is a API and that API is running on 443. So export that means forward port forwarding, you can do that and access that particular port number. And after that, we can do that. The main purpose is that we should be able to listen that ports or listen that ports where the application is running. Understood?
Yes, sir.
All right. Now, see, creating a virtual machine is a manual process, but DevOps is automation. So DevOps engineer says, oh, this is basically, this is okay. We are somehow able to resolve this issue, but this is a manual process. So then Vagrant comes into picture. So what is Vagrant? Vagrant is the HashiCorp HashiCorp uh, tool. So what it does, it is basically creating the virtual machine through a script, and that script is written in the Ruby and Rails, Ruby scripts, right? So I'm not going to discuss this Vagrant, not required, right? But you know, uh, this is means I will share some tutorial with you which is related to Vagrant if you are interested to learn Vagrant. So you can go through that one. But we were using Vagrant. So what Vagrant will do? Now consider this is a development machine, and you want to deploy the code. So what I will do as a DevOps engineer, I will write a script. So whenever you are going for the automation, best way is the script. Okay, write the script. So that's why scripting is very important for Linux administrator point of view, DevOps engineer point of view. So I was writing that script into the Vagrant, which creates a virtual machine. There are some, uh, virtual uh, operating system images were there, right? So those are Ubuntu, CentOS, right? So there is a huge community there, those who are contributing to the Vagrant, right? So I was writing the script, and whatever I was doing manually to create a virtual machine, everything I can script out, even though I can give the private IP addresses also. And I can do the port forwarding, I can execute a set of commands also. So now this made my life easy, right? Because I will create a script as per the development requirement, means they want to deploy it. Now, same script I will, instead of creating that manually, same script I will execute it on the testing environment. Same script I will execute it in the production environment. So my life is easy now. If something is not working in this script, in this particular virtual machine, right? And that virtual machine is getting created by the script. So it will definitely not work here. All the path and everything is inside the virtual machine only. So that was good. Now let me just discuss one thing, which is the virtual machine related architecture. So virtual machine in the companies, there is a separate team which is virtualization team. Right? In virtualization, we say everything is virtual. When you are having a virtual box, right? So you are running on your Windows system, Linux and Linux operating system. You are running Mac. Okay. So every virtual machine behaves like a individual server, right? So now if we talk about the architecture of this Linux, this virtualization. So you are having this physical server. Physical server is a machine, physical machines. Now here at the bottom, you are having the infrastructure. Infrastructure is nothing but your hardware, like RAM, CPU, hard disk, etc. On top of that, you are having something called hypervisor. So what is hypervisor? See, hypervisor is the one which is used to manage. This is used to manage the virtualization. See, we are connected to this meeting, but we are virtually connected to this meeting. It looks like that we are sitting next to each other, but it is not, right? So same way, whenever you are creating any virtual environment on your physical server, so it behaves like a single virtual machine, and single virtual machine behaves like a single physical box, right? So on a single system, you can create multiple virtual machines. Now, this one which I'm talking about, this is called type 1. In type 1 it is mostly used for the production, staging, right? UAT, etc. Means the virtualization team, they are mainly working on the type 1 virtualization, where they are having one physical box. On top of that, they need to create multiple virtual machines, right? So hypervisor is required. There are many hypervisors are uh, in the market. The one which is very popular is VMware. Almost 70% of the industry of the virtualization is running on VMware, right?
Zen
So
is also hypervisor, no? Zen.
yes, Zen is also hypervisor. Hyper-V is also so. Yes, so this is Citrix. Hyper-V is from Microsoft. So there are many, but widely used is VMware. So you need not to install a host operating system first. You just need to use the hypervisor. On top of that, you need to create your virtual machines. So each virtual machine is having its own isolated environment. For example, if you are creating two virtual machines, so they are isolated to each other. Okay, until unless you define something that we need to set up in networking, etc. So now here we are having the guest operating system. When we say guest, it is virtual machine. Okay, virtual machine operating system. And this operating system is a complete operating system with kernel. So what is kernel in an operating system? Anyone can tell what is kernel in an
The
operating system?
kernel is a brain of an operating system.
Hmm. So what it does?
Interacts with the hardware and manages all the CPU, memory devices, everything of the operating system.
Very good, very good. So kernel is, as you mentioned, it's a brain, it's a core part of the operating system. See, with the kernel, whenever your application runs, your operating system kernel is going to talk to the hardwares. For example, it needs memory, CPU, or other hardware devices. So that request goes to the kernel, and kernel talk to the hardware, and hardware response comes to the kernel, and kernel is giving it to the application. Without kernel, you cannot have the operating system. See, Linux is not an operating system. Linux is a kernel. Okay, so Linux is a kernel, and Red Hat is an operating system. CentOS is an operating system. So without kernel, an operating system does not exist. So whenever we are creating a virtual machine, so we are basically having a complete operating system with kernel. On top of that, we are having the binaries. Binaries or libraries are nothing, but these are the, uh, you can say these are the middleware. Middleware means, for example, you need Tomcat server for Java-based application, or you need the Gunicon for your Python. You need IAS for .NET-based application. So those are the binaries. And also you need, for example, um, JRE is to be installed, Python is installed, .NET is installed, right? So those all are the binary which are required to run your program. And then on top of that, you can run multiple applications, application 1, application 2, application 3. Similar way, you can have multiple virtual machines on your single physical system. This is called type 1 virtualization. Any question? All right.
Okay.
So now
What is the name of that type 1 virtualization? Like there is one
it
more
is called
virtualization machine.
type 1 only. It is called type
Type
1
1.
only. And this is how the virtualization team in your company, they are basically creating the virtual machines like this. So for example, you want, whenever you are connecting to any virtual machine, so behind the scene, this architecture is basically developed. Okay. Now, let us talk about type 2 virtualization. In type 2, basically what happens that we are having a server, right? It can be a server or it can be a virtual machine also. Okay? It can be a server or it can be a virtual machine. So on top of that, we are having the infra, which is the hardware. On top of that, we are having a host operating system with kernel, right? Complete host operating system. So consider this is a physical server, not the virtual machine, physical server. We can use the virtual machine also, but to understand easily, consider your laptop. Okay, on laptop you are having hardware. On top of that, you are having Windows 11, which is the host operating system. Then on top of that, you are having you have installed the hypervisor. Okay? On top of that, you have installed the hypervisor. Hypervisor means this virtual box, VM workstation. So these are the hypervisors. And then on top of that, you have created your virtual machines, right? So this is type 2, similar to type 1, but now this time hypervisor is not directly talking to the hardware. But here, the hypervisor is talking to the host operating system. This is type 2. So the one which we are using in on our system, so that is basically the type 2. And in production, in real time, which is used for supporting development box or production machines, we use type 1. Okay. Now let us understand one thing. Then we will see why we need to move out from the virtualization to containerization. See, now you are having a virtual machine, right? So development machine you have created as a virtual machine. See, creating a virtual machine is it takes time, even though we are using Vagrant also. So it takes time and there are some challenges also. So earlier, what we were doing, we were having applications like uh, monolithic application. What is monolithic application? Consider that you are having one banking application, right? So in this banking application, you are having, say, an example, withdraw service. You are having deposit. You are having, say, an example, mm, internet banking, and many others. So everything is embedded into a single binary, single executable file. So that was the case when only physical servers were there, right? When waterfall methodology was mostly used. So the main disadvantage of this is number one, vertical scaling. Number one, scaling. Scaling is a process where you manage the traffic. You adjust your hardware or infrastructure on the basis of the workload which comes to the application. So, so we were using the vertical scaling at that time. So what is vertical scaling? Vertical scaling is a process where you, to handle the traffic, you increase or decrease the hardware capacity. If we say, I want to increase the hardware capacity, for example, you are using 4 GB RAM, you increase to 8 GB RAM. So this is called scale up. Okay, if someone says scale up, it means they are talking about the vertical scaling. If you want to remove some hardware from 8 GB RAM to 4 GB RAM, okay, it means you are decreasing. So this is called scale down. So scale up and scale down. So you are managing the traffic which is coming to this application, and that is you are doing scale up and scale down. So the problem was because it's a single physical server, right? And at that time, hardware was very costly when I'm talking about before 2000, right? So at that time, this process for scaling was used, but there are a lot of disadvantages. If you compare with the latest technology, right? So this was totally different. And today we don't do like this. If you are running monolithic application, it means these are the legacy applications. So we use the loosely coupled approach. Okay. So vertical scaling was used. There are a lot of disadvantages. Number one, if you are adding a new hardware or increasing the hardware capacity, you need to shut down the application. But these days, we cannot afford to shut down the application. See, have you ever seen Google is down? No. Have you seen Facebook is down? Have you seen uh, Platform X is down? No. All are always up and running. And same behavior is for the other applications which you are supporting. It should be always up and running. But if such kind of situation occurs, then you need to shut down the application. There is no other option. You might have received some messages from banking or your internet service provider. We are doing some maintenance, so service will not be available from this time to this time. So it means they are doing something related to the vertical scaling. Now, as the time changed, virtualization came into the picture. Virtualization came somewhere in 1998 to 2000 at that time. Okay. So then the development approach is changed. Then we start working on the business access layer separately, data access object separately, presentation layer separately. So we are dividing our code into the different layers. But still it is, whenever you are executing it, you are adding those jar files into that particular part of the application. For example, you want to use the presentation layer and you need the business access layer. So you need to embed or you need to import complete jar file into your presentation layer, and you need to include, but development of these business access layer and data access objects, so these can be separate, and you can reuse it into, for example, you are developing a web application, desktop application, right? So in that case, you can reuse these means same business access layer .jar file. You can use it in both DAO. You can use it in both. So that was the advantage. So that is why virtual machine came into the picture, and now we are having the horizontal scaling also. So what is horizontal scaling? So to handle the traffic, now you are increasing the number of virtual machine, okay, increasing the VMs. So this is called scale out. So if someone says scale out, so scale out means they want they want new machines to be added. And if you want to remove, decrease VM, then this is scale in. So these are the four terms. Scale up and scale down is used for vertical scaling. And for horizontal scaling, we use the term scale up, scale out, and scale in. Okay. So now if there is a lot of traffic comes, so what you are doing, you are putting one load balancer in between. So this load balancer is having some registered virtual machines, say virtual machine 1, virtual machine 2. So now there is a lot of traffic comes. Now that traffic is distributed to the virtual machine 1 and virtual machine 2. Right? Now, if you need more, then you can simply, without shutting down your application, you can add it into the virtual machine 3. So it is a copy of this virtual machine 1. Consider same image is used. So that way we can handle. Do you understand physical monolithic application, layered approach, scaling? Any question?
No, sir, clear to
And
me.
Manishika?
Yeah, yeah, no doubt.
Oh, all right. Now, next is that, uh, right. So next one is basically time get changed. Now, this layered approach is in the form of APIs. And APIs further extension is microservices. Now tell me, the development of the layered approach is a loosely coupled or tightly coupled approach?
Loosely coupled.
Loosely coupled, right? So when we are developing separately business access layer, data access object, and others, right? Now, because the time get changed and There are different Internet of Things are there. So a single, for example, if I'm developing something for Windows, it will run only on Windows. If I develop something in Java, it may be you can run in different environments, but you know the data when it is getting exchanged between the multiple application, we need something common thing like XML or JSON. So that is why means I'm not going in very detail about the microservices, but you can develop the microservices in different programming languages, Java, .NET, Python, right? So now, what is microservice approach? Consider that I'm having this banking application. Now, I need to develop a banking application. For this, I need, say, an example, internet banking. I need, say, an example, withdraw service. I need something called deposit service. I need something called um, customer care. Now, if I create application microservice, something like this, I will create a separate internet banking. I will create separate application for withdraw service. I will create separate application for deposit. Consider you are creating the jar files and embedding it into the microservice. That approach is called layered approach. But now consider this is a separate jar. 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 Now I'm not embedding into this. Embedding means I'm not importing it inside the banking. Instead of that, this banking application is invoking. So there will be a URL. Okay, there will be a URL, or we call URI. Okay, so there is a URL for each application, and these all applications are deployed on somewhere. Okay, some web servers. And now what this banking application is doing, this banking application is calling these microservices instead of embedding it inside it. So this approach is called microservice approach. Right? So whenever, so who basically works on this? Development team. They develop it. As a DevOps engineer, we don't develop it. Now, they have developed internet banking. So they want or banking application, uh, you know, this customer, he wants that my application should be always up. Internet banking should be always up. Withdrawal service should be always up, right? But consider you need to make a change into the internet banking. In that case, you need to shut down, right? If you want to make something into the withdrawal service, you need not to shut down the entire application, but only that portion is to be removed. So this is a very, very good approach, right? Because if we talk about the monolithic application, so in that case, you need to shut down the entire application, even though you are making a change into the customer care application. So that kind of approach is changed. Now consider if I create a separate VM for this, separate VM for this, separate VM for this. Consider all are developed in Java and I need the tomcat server. So I need a tomcat, or maybe in single machine, I deployed everything. Now, if I need to, uh, deploy, consider this is a single machine where all these services are deployed. Now, what you need to do, you need to update your internet banking application. So for that, you will shut down this, right? This portion, and your banking application will throw an error when someone is trying to access during that implementation, and then you will update this. Or it may be possible that you are having multiple virtual machines, right, where you are having these applications deployed. So it depends, right? But internet banking is down at that time when you are implementing, which customer does not want. Customer wants that if Google is up all the time, why not my application? So that is why we are not going to use VMs, we are going to use containers. So containers solves that problem. We will understand architecture and other thing. So I will deploy it as a container, and it is very early to say that how that problem will be resolved if I update internet banking with other its enhanced code, then how we can prevent the downtime. So it is early because that we will discuss in Docker Swarm or Kubernetes, which is the container orchestration tool. So now I will deploy my application as a container. So this will be a container, this will be a container, this will be a container. That container could be on a single machine or in a cluster. So these all are the containers. Do you understand what problem containers are resolving?
Yes. And so what is cluster?
Yes.
Cluster. So cluster is the collection of machines. For example, you are having one server and there are some client machines. Okay. So we will develop a cluster also in this Docker Swarm. Okay. So cluster is the collection of machines. Okay. But you understand the what problem that container means. We will see the practical implementation also. So containers are mainly used for the applications which are similar to the microservices. It could be web application, it could be your DB, it could be anything. So if you think that we can run it as a container and then yes, go ahead with that. Now, so now here is the one good thing is that this is web applications may not be the microservices, right? But you are saying that okay, my web application should run as a container. If it can, then yes, we can do that. So there are few things which we cannot do by using containers, right? Like for example, you want to run a desktop application, Windows based. So those things we cannot do. Um, when I was taking a training for one of the company and they mentioned that they are running one Docker image which is 7 GB. So so those things also uh, we need to prevent, right? 7 GB that Docker image size is huge, right? So if you think, right, that will be your call, your intelligence when you are, you know, working as a DevOps engineer. Do I need to go with the containerization or not? Okay, this is not like that. Containerization is a technology I have to use. If required, then use it. And I'm telling you the use cases, your microservices, your database, etc. In in real time scenarios, whatever we are using in the form of virtualization, Most of the things we can convert it into the containerization. But for that, you as a DevOps engineer, you need to work with the development team and you need to understand how they are developing the code, right? And if you need to implement, then how to implement that code. Can we go with the containerization, or if it is a isolated application and it is not following the DevOps process, then you can say, okay, in that case it can be a virtual machine you can take and install it over there. But as a DevOps engineer in the automation, we mostly go with the containerization these days. So this is the modern technology. Now, next question is how we can create this container. So for that, there are different tools. Docker is the one which is, you can say, BAP of all, right? So Docker is the one which is mostly used. It is not like that you need to use Docker, but Docker is the one which is widely used in the industry level. Second is containerd. That is also container runtime. We call it container runtimes. There is Rocket. That is also with the help of that you can create the container. Runc is also there. So like that, there are many. But we are talking about the Docker. Now, why Docker? Because Docker has one thing monopoly, and that monopoly is the Docker image. All these containers, all these container runtimes, they don't have the capability to create the Docker image or to create the container image, or if I say. So Docker is only the one which creates the Docker image. So that's why Docker is having the monopoly. Okay, so if you want to create a container, you need a Docker image all the time. If you need the Docker image, it means Docker requires. Tomorrow, if you say, okay, runc is gone, or a new container runtime comes into the picture, they need the Docker image. So Docker dependency is always there. Okay, so that is why Docker, and Docker is also, it creates the containers. And we will talk more about this, once we proceed to this, particular, set of lectures. Now let us see how Docker engine or how Docker works. Now this is your physical server. On top of that, you are having the infrastructure. On top of that, you are having the host machine or host OS with kernel. It can be a virtual machine or it can be a physical server. On top of that, you need to install a hypervisor. Oh, sorry, not hypervisor, my bad. You need to have the Docker engine. Docker engine is responsible to handle all the Docker related stuff, whether you are creating Docker image, whether you are creating a container, networking, etc. On top of that, we are having binaries and we are having the application. This portion is called container. So your container is having the binary plus application which is running on top of that. Now, container is using something called Docker image. Now let us understand, and you need to understand this Docker image before understanding the container, because Docker image is the base of that container. Now, let me ask some questions. If I ask you, you need to run a Java program on your machine, what will be your first step? If I ask, you need to run a Java program on your machine. So you need to install Java, right? Without installing Java, can you run the Java program? No. If you want to run the Python program, you need to install Python first. But I am saying, no, you need not to install Java, but you can run the Java program. Hey, how it is possible? It is possible if you are having the containerization. So Docker image is something like this. Docker image is it is only as per your requirement. So what you will do, you will create a Docker image. Some of the Docker images are already there. You need not to create from the scratch. Like Ubuntu operating system Docker image is there. So what you can do, you can take this image and on top of that, you can install Java. Then take this image and run it as a container. So when you are running as a container, so everything is inside the container. So container is running on top of your host operating inside the container. It means I need not to install Java or JDK to run my program because it is inside the container. I will go, it's just like a virtual machine, right? So now we compare with the virtual machine, but it is not required. Virtual machine concept is totally different and containerization is different. But yes, for understanding point of view, let us compare with that. Consider this is a virtual machine which is having Ubuntu and Java installed. Now, if you go inside that, you can run the Java program. Same thing we are doing with the containerization. Similar way, right? Uh, if someone says, I need a CentOS machine and I want to install Python on top of that. So yes, let us go and create a container with CentOS and install Python on top of that, then use inside this. Now these containers are running on inside your machine. So they are isolated. So it means on your machine, host machine, you need not to install Python. You need not to install Java. You can run it inside the container and you can use it. Now uh, another purpose of or another advantage of Docker image is that it is without kernel. It is without kernel. Without kernel means in the Docker image, there is no kernel. If there is no kernel, then how this operating system is there? This operating system is without kernel. Kernel is a major component in your operating system, right? So now, if you see the Docker image of Ubuntu, it will be hardly 80 MB. And there are some light versions which we call Alpine images, which is 8 MB only. So you will see the Docker image is 80 MB, 8 MB, and entire operating system, but without kernel. Consider you are having one, two, three, hundreds of containers running because these are lightweight and microservice development should be in such a way that whatever is required, see if you are running internet banking microservice, so it will consume very less memory and CPU. So you can run it as a container. Okay. When you run it as a container, then basically what will happen? You can run multiple containers on a single machine. Hundreds of containers we can run. Hundreds of virtual machine you cannot create, means you can create, but you need a very big infrastructure for that. But running hundreds of container, you don't need a big infrastructure. On my this machine, which is having 24 GB RAM and, I have a 4-core CPUs. So I can run if 8 MB into 100. I needed 800 MB memory for this, and I have 24 GB. So I can easily run hundreds of containers, but hundreds of virtual machines I cannot run because each virtual machine, for example, I need 2 GB. So 2 GB into 100 is 200 GB. I don't have that much uh, RAM capacity. So these containers which are running with the Docker image, and Docker image does not have the kernel, they use the kernel activities from the host machine kernel. Guys, just give me 1 minute, just 1 minute. I'll come back. All right, I'm back. So what I was saying, so I can run hundreds of containers, right? So that is what companies want now to run their applications. So if one container is not working, we can create a replicated container that we will discuss in the container orchestration. So the thing is that if this container is running, right? If this container is running, it needs to run the application, and application needs memory, CPU, because there is no kernel here. So it will use the kernel of the host operating system. If if there is one application running here as a second container and it needs the memory and CPU, it will request to the Docker engine, and Docker engine will request to the host machine kernel. So this is what we use in the containerization, right? So
Can you just
all
repeat the
the
last what about this
okay,
thing?
this one. So consider there is another container running. So that also running with the Docker image, and Docker image is not having any kernel, and this container is running and it needs some memory and CPU. So the request will go to the Docker engine, and Docker engine to the host machine kernel to to take the kernel related activities like to contact to the hardware and get the RAM and CPU to this particular container. Not only for this also, or whatever the containers we are having on our single machine, everyone is using the host machine kernel only. So host machine kernel is shared with all the containers. Now there is always a question that, okay, can we install this Docker? So I'm talking about Docker engine only, okay? Can we use can we install Docker on Windows? So answer is yes. We can have Docker on Windows. Now Windows kernel is different, differently programmed. And on top of that, on Windows machine, I'm running one Ubuntu machine. So Ubuntu is Linux, and it needs running as a container, and it needs the host kernel for running its application. Is it possible? The answer is yes. So Windows kernel is updated in such a way that it can support the containerization, okay, which is the example which I'm giving here, Ubuntu machine. They needs the kernel related activity from the host machine kernel, which is the Windows. So that can be possible. So the modern kernels, so they are basically Windows machines. So you need Windows 10 plus or Windows 11, it is already there. But if you are running with the Windows 8 or previous version, their direct support is not there. You need to install certain tools. So this is my
So
containerization. Yeah,
we need to install Docker engine everywhere,
on
which
the
is an inbuilt
operating
feature
system. On the operating system.
on the operating system.
Yes. Not
Okay.
in some tools. If we are installing it on Jenkins, for example, so in Jenkins, we need to install the plugin, not the, we need not to install completely. Is this part is clear to both of you?
Yes, sir.
Yes.
Okay. Um, I will actually, notes are on the way, but I have that website which I have shown you earlier, devopsworld.co.in. And here I have this Docker. Uh, so here, Docker. So, so whatever I have discussed, everything is here. And let me just go to this. So this is the logo of Docker. Okay, this ship is having multiple containers, and this is monolithic Docker platform. Let me just try to explain this one. So this is Docker engine, right? Docker engine which take care of the all the Docker related activities. So now in this Docker engine, what is its how it works? So this complete circle is the Docker engine. Now here we need to install Docker CLI. Docker CLI is nothing but command line interface. And with the help of that, we can run the Docker related commands. Like you want to run the Docker related command to container, images, Docker volume, networking, etc. So these are, we are writing in a plain English language, but underneath it has one REST API. So REST API is basically, that is the inside the Docker engine. So whatever command we are writing, it goes to this REST API, and REST API will convert that command into the set of instructions which Docker daemon can understand. So Docker is installed as a service, and that service is called daemon. So whenever we use the daemon uh, word into the into the any process related thing, so it is a background process. Okay. So it is running as a service. Okay, it is running as a service. So now, but this service can understand not this plain English language commands. It understands the set of instructions with which it is programmed. So REST API converts those commands into the instruction, and it sends the response to the REST API, and REST API further send it to the CLI. Means when we see the result in the background, this thing is happening. So this is Docker engine architecture. Now let us talk about the Docker architecture, how Docker works. See, when we are talking about the Docker, so in real time, basically what happens, uh, or we will do most of the thing on a single machines. But in real time, basically what happens, there is a Docker client. So what this client will do, it will run the Docker commands. And those Docker commands will go to the Docker host. So Docker host is a server where Docker daemon is installed, Docker engine is installed. And here we are having Docker images and Docker containers. Now this Docker images, right? So we download these Docker images from the some registry. See, to run a container, we need the Docker image. And from where we will get the Docker image? From the Docker registry. Now this registry can be global, means on the internet. It can be private. Within your own organization, you have created one server and you keep your Docker images over there, right? So first we will discuss global, which is on the cloud, like DockerHub. DockerHub is the official website where you will find the Docker images. And private, it can be your private repository, or maybe on Azure you are having a private repository, container registry. On AWS you are having ECR, Azure Elastic Container Registry, right? So ultimately on my system, I need this image and I can download it from some registry that can be global or private. Once that image is available, then I can create the container, and that is under Docker daemon, and Docker daemon is running in under this Docker host. So this is the overall Docker architecture. Now time to execute. Yes, we have discussed theoretically everything now, right? Now it's the time for the execution. So let us implement it. So what I will do, I will install Docker on my, you can install it on Windows, but it is for Windows, it is little bit heavy. It may slow down your system. So I will use Ubuntu operating system and I will install this on the Ubuntu system. So for that, you need not to do right away with me, but I will share the commands and other things. So you just uh, try this offline. Okay. So now I'm taking one Azure machine because my Azure, or you can create on AWS, wherever, or your virtual box, whichever is suitable to you. We need the Ubuntu operating system. So I'm just going to create that one a portal.azure.com. Okay, so I will create one virtual machine. And I'll create a virtual machine quickly. I will call it as Docker VM. Okay, availability on this is fine. This is fine. This you don't need the, if you are using AWS, take the T2 micro. Okay, I don't need this big one, but for it is. So there, actually here, the good thing is that I can create the username and password. and I want to open port number 80, 443 and 22. Next, next. I will use everything as it is, and I'll say review and create. Validation is passed. I will open mobile extern. Meanwhile, I have created so many virtual machines. So Ubuntu is basically, oh, I have selected Ubuntu, right? One second. Linux. Yes. So this is the public IP address. I will use this one. Username is Raman. Okay. And I need to give the password. So I will check. I think I have selected Ubuntu only. Hostname CTL. Yeah, Ubuntu 24.04. Okay. So first, let us log in with a root user so that we should not have the permission issues. Right. So now apt is the repository, right, in Debian-based system like Ubuntu. So we need to update this repository so that we will have the up-to-date, that softwares or packages. Now to install Docker, you need to say apt install docker.io. Minus y means if it asks a question yes or no, it will take yes. So Docker is installed. How do you know Docker is installed? We can say Docker hyphen hyphen version. So Docker is installed. If you want to see what are the commands, okay, to see all the commands related to Docker, so you can run Docker hyphen hyphen help command. Okay, now here you will see that there are many commands are there. Let us understand this. See, these are commonly used commands. In the common commands, you will see run command, exec command. So these are very commonly used. Second is the management command. Management commands are those commands which are related to certain context. For example, if I want to run something related to container, so Docker container, and then we will write the command. Okay. If I am writing something related to image, Docker image, then that command. Right. So now there are some other commands, Docker Swarm, which is the container orchestration we will discuss. And these are all other commands. Right. So now if you want to, we will see that time to time, whenever we are going to use these commands, we will see the help of that also. Now, first thing is that to start to start, we need the Docker image first. Okay. So we need to have the Docker image first. For that, we will use Docker image from DockerHub. As I mentioned, DockerHub is a official website, or you can say official repository maintained by Docker. Docker is a company, okay, and it is maintained by the Docker. So we'll go to the Docker website, which is hub.docker.com. So uh, this is the hub.docker.com. This is the website, and we can find public Docker images which are commonly used, right? Means, for example, Ubuntu. You you need not to create the account in DockerHub to download the Ubuntu Docker image. Okay. So public Docker images means you do not need to create account on DockerHub to download these images. Okay. So these are publicly available. Example, Ubuntu image, centos, tomcat, Java, Java, etc. We can also create the private images, means our own. Okay, we can also create the images, which we can also create the images on Docker Hub. For that, we need an account. So what we will do, we will create the account, because we will practice that also. We will push our Docker images to the Docker Hub. So what I will do, I will go to the uh, I will go to hub.docker.com, and I will, here you can search see, I did not sign in so far, but I want to download a Docker image, say Ubuntu Docker image. Okay. Now how to get that image? Here it is saying this is the Ubuntu official Docker image. See, if you see this kind of tag, so this is the official Docker image, means it is created by the Docker engineers only. If you see something like this, which is this tick mark, this is a verified publisher. For example, Microsoft. So Microsoft has created some Docker images and they want to publish it on the Docker Hub. So Microsoft is a branded company, right? So we can trust. So if something is created by Docker official or verified partner, so we can trust on those images. We can consider that, see, Docker image is very crucial for your deployment, your application deployment point of view, because for example, if I create some Docker image and I give it to you, and in my Docker image I have written something that I can steal your data, so I can do that. So it means whenever you are using someone else Docker image, you need to scan that. And how to scan that we will see. But you need to scan, you need to make sure that it does not have any vulnerability. So vulnerability is basically a concept which if some Docker image is vulnerable, don't use that because it can harm your system. Okay. So or it is having some loophole related to security. So let us first check this official Docker image. When you are using official or verified, you can trust. Okay. That is what I mean. But if I create and give it to you, you need to scan it first. So I want to search the Ubuntu again. Okay, Ubuntu Docker official image. So here you can see it is saying if you want to download. Uh, so what we will do here, you can see recent tags. So we will go with the latest. Right. So now what it is saying that tag we will discuss. Right. If you want to run this, then earlier they were giving one command here. Okay, that command is not here, not here, not here. Run with Docker. Okay, let us see. Here. Docker pull Ubuntu. So you can copy this command. So what I'm going to do, I'm pulling this image. If I say Docker and pull Ubuntu. Okay, so what it will do, it will go to the Docker hub. First, it will check in the local, right? But there are some naming convention. If I say Ubuntu like this, if I say Docker pull Raman, Raman is not a Docker image, but it will go to DockerHub and check whether Raman image is there. If it is there, then it will download it. Otherwise, not. But let us go with the Ubuntu first. So now what it is doing, it is going to DockerHub. If you see here, docker.io/library Ubuntu latest. And there are some information we will discuss those information also. Now what I have done, I have downloaded Ubuntu Docker image. How do you know? Now to list the Docker images, what we can do, we can run the Docker images command, or we can use Docker image ls. So this is a management command, and the other one is commonly used command. So if I run Docker images, or if I run Docker image ls, both gives you the same result. Now let us understand these things. Uh, what are the things in this list, right? So first of all, we have executed this command, Docker pull Ubuntu. When we executed this command, it goes to the Docker hub and downloaded that on my machine. The size of this Docker image is, see, 78 MB only. Ubuntu image, Ubuntu, if you download the operating system, it is 5 GB, 6 GB, 10 GB, it will be something like that. But it is 78 MB because it is lightweight. We call it lightweight because it is without kernel. Now, second is a tag I will discuss. Second is the image ID. So image ID is the unique image ID. It's a ID of that image, and it is always unique. Two Docker images cannot have the same Docker image ID. If they are having, it means they are same Docker image. When it is created 2 weeks ago, I have downloaded just now, but it has created on the Docker Hub 2 weeks ago. Okay. Now, what is this tag? Consider you are working with Ubuntu 24.04 or 22.04 or 20.04. So you need these Docker images. So these Docker images are with different tags. This is having different tag, this is having different tag. And every image will be different. See, Docker images are read only. you cannot update a Docker image. Okay, Docker images are read only. Once the Docker image is created, you cannot modify it. If you want to modify, you need to create a new Docker image. If you create a new Docker image, there will be a new Docker image ID. Okay, so that one thing you need to remember. Now, if I want 24.04 or I want from where I can get this tag information, you can come over here, right? Here you can see supported tags 22.04. So you will find these are the tags. So you can use if you don't mention when you are downloading the Docker image. So for example, if I come over here and if I say Docker pull and colon 20.04, sorry, 20.04. So what it will do, it will, because 02 was not a tag, supported tag. So now if I say Docker images, so you will see that there are two Ubuntu Docker images. One is 20.04, one is latest. If you don't mention anything, it will always take the latest one. And see, the image IDs are different for both. This created 10 months ago. This created 2 weeks ago. The size of this is small. This size is. You guys are following me? What I'm doing, Manishika?
Yes. Yes.
No, you are understanding what is happening.
Yes.
Yeah, maybe means I will upload this video, and then you can just revise this when and then you can do the hands-on. Nikhil, you are understanding?
Yes, sir. For me, it's clear.
Okay, good. Now see, likewise, there are many images. For example, if I say you can go there to the DockerHub and you can say Docker pull tomcat. So you can download the tomcat Docker image. So in that Docker image, tomcat is already installed. You need not to install it on your local system. Same way, you want to install Docker, you want to pull Docker image, say CentOS. Okay, CentOS latest is not there. Okay, so they are saying you can go again to the DockerHub and you can check. See, Docker CentOS 7 is there. No, if I say Docker images, so you will see all the images there. Now I want to delete some. See, Tomcat is 416 MB, which is a big in size because it has Tomcat installed inside that. So because of that, the size is increased. CentOS C 204 MB, and all are having different image ID, different tags. Now let me delete. Now to delete a Docker image, not from the Docker Hub, on your local system. You have downloaded, now you want to remove. To delete the Docker image from your local system, we use Docker RMI and then the image name, or you can use Docker image RM command, and then both are same. Okay, one is management, one is commonly used. Now I will say Docker RMI and I want to download Tomcat image. So you need not to mention colon latest. By default, it is latest. So what it will do? It will delete. Now, Docker image. Okay, let me just explain one more thing related to Docker image. So first of all, Docker images are read only. Second thing, Docker image is not a single file. Docker image is collection of some encrypted layers. Encrypted layers, or you can say encrypted files. We call it layers. So those are the encrypted layers. See what I have done? I have removed the Docker image Tomcat. But see, this is removed, all get deleted, right? So these are nothing but these are the supporting files for the Docker image. So Docker image is not a single file most of the time. It is the collection of some encrypted layers. Okay, so that is also one thing you need to remember. So that is why when I deleted Tomcat, it has deleted all these things. Fine. Now, next is I want to delete CentOS image. So I will say Docker RMI or image RM CentOS. It will not work because I don't have the latest tag. I have CentOS 7. So I need to mention :7. So wherever it is required to mention the tag, you need to put colon and then the tag name. So now my CentOS 7 is removed. We can check Docker images. So you can see CentOS is removed. If you are having hundreds of images and you want to find out a particular image, then you can say Docker images and the image name. For example, I am searching for Java. There is no image for Java. I want to search for Ubuntu. So there is a Ubuntu Docker image too. If you want to search Ubuntu colon 20.04, yes, there is one image. If you want to search for Ubuntu 24, 20.02, so that does not exist, right? Now there is a special directory when you install Docker. Docker related stuff gets stored into that. So if I say ls slash var slash lib slash docker, okay. So this is the directory in the Ubuntu system which stores everything like images, network related, container related, volume related, swarm related. So Docker is maintaining everything here. Is it clear to up till here how to download the Docker image, how to see the Docker images, and Docker images are read only, we cannot modify it.
Yes,
Okay.
sir. Yeah.
Okay.
Oh,
So let's wind up today's session here because uh, you need to revise this also. And tomorrow we will create the containers. Tomorrow we will see a lot of practical commands. We will see how to create the containers, how to access the how we can deploy the application inside the container, how we can do other stuff like Docker container volume, create our custom Docker image. Okay, so we will continue our discussion tomorrow. All right.
Sir, I have Docker desktop installed in my setup.
So
So,
if you have Docker installed, then what you can do, you can directly go to the command prompt and you can run the command docker hyphen hyphen version, right? So like here, Docker
okay.
is installed. Now you can run the Docker pull and Docker images. So you come. So what it will do, it actually, let me see, my Docker desktop is, I was facing some challenges. Let me see. So if you install the Docker
27.3 version.
0.3 version, that is also fine. So Docker is running with one, yeah. Sign in. Okay, let me sign in. Right. So it is getting started. So this is a kind of a GUI also. So Manishika, you can also try to install Docker on your Windows machine. Okay, instead of if you don't want to create a virtual machine separately. So for that,
okay.
just go to Google and search for the uh, Docker installation uh, on Windows. Okay, so there is a desktop. It's a wizard. You just click next, and it will install. Okay. So now Nikhil, you can see here that we are having this. Now what I'll do, if I go to images, right, I have these images. So I will say Docker pull and Ubuntu. So what I'm going to do, I'm going to download the Ubuntu Docker image. So you can run the commands which let me share these commands also, which I have executed here. Let me share these commands. Let me put it on the chat window. So now I pull that image here and right, view a summary of the vulnerability Docker Scout. Okay, that is different. So now if I say Docker images, so now I have the image which is Ubuntu latest. So you can see here as well as you can see in the desktop also. Okay. And this will give you some more like you want to analyze, etc. Those things you can do it. We will discuss this desktop version also.
Awesome. Tomorrow.
Yeah, tomorrow or maybe in next class.
Tomorrow, what time do we have class?
You're okay with 7 to 9 or you want 7:30 to 9:30?
7:30 to 9:30 will it's really fine for
Mm,
me.
Okay, so let's meet 7:30 to 9:30 then.
okay.
Sure.
All right, see you tomorrow, guys. Bye bye.
Yeah.
Have a
Thank you,
good day.
sir. Bye.
Bye. Thank you.